Computer is like a kitchen in a hotel, and the central processing unit is like a chef in that kitchen. As a chef prepares food, the central processing unit processes data in the computer and converts them into information. As the food preparation speed depends on the speed of the chef, the speed of the computer depends on the speed of the central processing unit. A dual-core processor is like having a kitchen with two chefs preparing two meals. So, two things can be prepared at the same time. Chapter 1.1. Let's identify the central processing unit. The central processing unit (CPU) can be identified as a digital circuit that processes data according to given instructions. Whatever task performed by the computer, in all such instances, the central processing unit runs in the background. The main function of the processor is to execute instructions stored in a computer program. That is, it gets data and processes them according to given instructions. Here you can see 1.1 figure, central processing unit. While the central processing unit can't be observed from the outside, it is positioned fixed on the motherboard inside the system unit. In figure 1.2, location of the central processing unit. First one, system unit, second, motherboard, and third one is central processing unit. 1.2. Let's identify the components of the central processing unit. The central processing unit consists of three main components: ALU, arithmetic and logical unit, CU, control unit, and memory register. 1.2.1 Arithmetic and logical unit (ALU). Mathematical and logical functions are performed in the arithmetic and logical unit. The functions of this unit can be further divided into two main sub-functions: mathematical functions, logical functions. Mathematical calculations such as addition, subtraction, multiplication, division. Example: 2 plus 3 is equal to 5. Logical functions, logical operations such as comparison of two numbers. Example: 3 is greater than 2. 1.2.2 Control unit (CU). The control unit communicates between, manipulates, and controls the hardware connected to the computer. It also performs tasks such as controlling input and output data, ensuring that data is sent to right place at the right time, and being alert whether relevant signals are successfully received. 1.2.3 Memory registers (MR). It temporarily stores data and instructions that are being used by the central processing unit. The storage capacity of the memory registers is very low when compared with other memory devices like hard disk. However, its data access speed is very high. 1.3 Let's learn about the evolution. The central processing unit of a computer system can be divided into 4 generations based on the electronic technology used to manufacture it. First generation, vacuum tubes. Second generation, transistor. Third generation, integrated circuit. Fourth generation, microprocessor. Let's see the first generation. Duration: time period year 1940 to year 1956. Electronic technology used: vacuum tube. Power consumption: a large amount of vacuum tubes About 18,000 were used and they emitted a lot of heat was required. A cooling system to control the heat, so it led to a heavy power consumption. Size of the computer as large as a room. Execution speed measured in milliseconds. Cost. It cost a lot for production and maintenance. Example: ENIAC, UNIVAC, and EDVAC. Let's see second generation. Duration time period year 1956 to year 1963. Electronic technology used transistor. Power consumption. Less power consumption when compared with the first generation computers. Size of the computer. Smaller size when compared with the first generation. Execution speed measured in microsecond. Cost. It costs a lot for purchasing. Example: IBM 7030 and CDC 1604. Let's see third generation. Duration time period year 1964 to 1971. Electronic technology used integrated circuit. Power consumption. Less power consumption when compared with the second generation computers. Size of the computer. Smaller size when compared with the second generation. Execution speed measured in nanosecond. Cost. It costs less for purchasing when compared with the second generation. Example: IBM 360, CDC 6600. Let's see fourth generation. Duration time period year 1971 to date. Electronic technology used microprocessor. Power consumption. Less power consumption when compared with the third generation computers. Size of the computer. Smaller size when compared with the third generation. Execution speed MIPS. Million of instructions per second and picosecond. Cost. It costs less for purchasing when compared with the third generation. Example: modern computers that are in use. Let's see speed of the central processing unit. Speed of the central processing unit, also known as clock speed, is the number of instructions executed in a second. The unit used to measure the speed of the central processing unit is hertz. In modern computers, the unit megahertz or gigahertz is used to measure the speed of the central processing unit. Learning never ends.